The Electronic Flight Instrument System, or EFIS, combines the information displayed on all these instruments and tuning panels into two 8-inch square display units. Let's look at how the primary flight display and navigation display show all this information. Each display combines the indications of several older style instruments into a smaller, easier to view area. Contrasting colors are used to make bugs and other secondary indications easier to find on the gray and black backgrounds. Before we look at the PFD, it's important to remember that this is only an overview of the EFIS. All indications are discussed in detail in later lessons. On older airplanes, you had separate airspeed indicators, attitude indicators, altimeters, vertical speed indicators, and secondary compass cards. Other panels provided indications for autopilot status and navigation radio tuning information. The PFD combines all of this data into one display. Let's look closer at each of the indications. The conventional round dial airspeed indicator has been replaced by a moving tape display. Larger numbers are shown at the top of the tape. Current airspeed is shown here. A speed trend vector reacts to changes in airspeed. Various speed bugs to indicate takeoff speeds and assist in flap retraction are controlled through the CDUs. They replace the adjustable bugs found on the bezel of most airspeed indicators. The maximum airspeed pointer is replaced by a red and black band. In addition, minimum maneuvering and stick shaker speeds are also displayed. Selected speed indications are controlled through the Mode Control Panel, or MCP. The MCP is located here on the glare shield. These are the airspeed controls. Individual controls on this panel are discussed in other lessons. The attitude indication should look very familiar. The ball-type slip skid indicator has been replaced by a small rectangle located beneath the bank pointer. Radio altitude is shown here instead of on a separate indicator.
Wind shear, wind shear, wind shear.
A pitch limit indication, or PLI, has been added to aid in stall and wind shear recoveries.
Climb, climb, climb.
TCAS guidance can also be shown. TCAS is discussed in a separate lesson. The round dial altimeter has also been replaced by a moving tape altitude indication. Larger numbers are also at the top of this tape. A barometric minimums symbol, which moves with the tape and changes color when minimums are reached, replaces the movable altitude bugs found on many altimeters. The EFIS control panel is used to set minimums and operate many other PFD and ND features. Current altitude is shown here. Selected altitude indications are also controlled through the MCP. The altitude indication can also display metric values, as well as landing altitude from the flight management system. Altitude indications are covered in detail in a later lesson. The round dial vertical speed indicator is simply stretched out vertically on the 777. Larger vertical speeds are shown numerically above or below the scale. Vertical speed controls are discussed in another lesson. The PFD also contains a partial compass card to serve as a secondary reference to the ND. The heading track indication shows current magnetic or true heading. Airplane track is shown by this pointer. A manually set heading bug is controlled through the MCP. In addition, a selected track bug is also available. Heading and track are also discussed in the ND lessons. Separate panels and indicator lights showing autoflight status and operating modes are combined into the PFD and shown here. ILS frequency or identifier, course, and DME, normally set with tuning panels and displayed separately, are shown together here. All navigation radio tuning is done through the CDUs and is explained in later lessons. Since we're discussing navigation, let's take a look at the ND. Conventional navigation instruments usually included a horizontal situation indicator or HSI, a secondary compass card with additional bearing pointers, and separate control panels for mode selection and navigation radio tuning. The navigation display combines all this information and much more into one area on one compass. The ND mode shown here is called centered approach and should look quite familiar. In this case, ILS approach information is displayed. Selected ND mode and radio tuning information are also shown. A similar mode is VOR. Differences between these modes are discussed in a later lesson. Both modes also have an expanded display. The enlarged display is easier to read and allows room to display weather radar returns as well as TCAS information. The EFIS control panel is used to select the desired ND mode, change the displayed range, and to display VOR or ADF bearing pointers. A third mode is MAP. This is the recommended mode for flight and the one you'll use the most. It also has expanded and centered modes. MAP displays navigation information from the FMCs. As the airplane moves, so does the map. Descent path guidance is also provided in MAP. Weather radar returns and TCAS information can be displayed in both MAP modes. MAP is a track up mode. This is an important difference between approach or VOR, which are heading up modes. A track up display lets you always see the course you want at the top of the display, instead of off to the side as with high crosswinds. Take a moment to note the differences in the two displays. Ever wished you had an easier way to see your entire route right in front of you? That is what Plan mode is used for. Plan displays non-moving map information in a centered format. One important difference about Plan is that it is always oriented with true north up. The airplane symbol shows where you are on the route. The legs page shows the waypoint at the center of the display. By pushing the step line select key, you can move through the route segment by segment. Push the step key until VAMPS is at the center of the display. Increasing the display range lets you see up to 640 miles of the route at once. Here the range is set for 320 miles. Decreasing the range and moving the display center allows you to look over an approach procedure hours away. Using plan mode during normal route entry is covered in a later FMC lesson. Even though these two displays seem rather crowded and confusing, you'll soon see how informative and easy to use they are. This completes the instruction portion of the Electronic Flight Instruments System Overview.